Welcome to Pre-Cal Trig Week 13. We're going to begin by reviewing inverse functions. We covered this last week. And as you get into the course announcements each week, you should have seen a video that you should have watched and reviewed the vocabulary. So we're going to watch this video if you haven't already. If you're watching the recording, feel free to refresh your memory. And then we'll come back and discuss how do you determine whether a function is an inverse of another function, and what test must you pass in order to be called a function.
If a function is a set of steps to do to a number, its inverse is just a different set of steps that undoes everything the original function did. For example, if we had one function f of x that told us to start with a number, subtract 5, and then divide by 2, its inverse function would instead do all the opposite operations in the opposite order. That means that it would start with the same number, multiply it by 2 first, and then add 5. Notice that we use this f to the -1 power notation to indicate an inverse function. Once we have a function and its inverse, we can check to make sure they are inverses by using function composition. If you're not familiar with this process, there is a video you can watch to learn about it, but basically it means plugging one function into another. The idea is that since inverse functions do the exact opposite things, if we compose them together, we should end up exactly where we started, just a plain x. Let's try this with our example above. Substituting f inverse into f means evaluating f of f inverse of x. Plugging in f inverse function wherever we used to see an x in the f function makes our equation look like this. Right away, we see the different steps canceling out. The +5 and the -5 in the numerator undo each other, leaving us here, and then the ×2 and divide by 2 undo to bring us right back to where we started, plain old x. This process actually shows us the mathematical definition of inverse functions. Two functions that, when composed with each other, cancel out and get us right back to the x on the inside. So now that we know what inverse functions are, how might you go about finding one? Say we have the function g of x shown here. What would the inverse of g be? Well, okay, since g of x is really just a different way of saying y, we could rewrite our function like this. Now, relying on the knowledge that the inverse is a list of steps that are the exact opposite as the original, we can use the following trick to find any inverse function. Switching the x and the y, and now solving the equation for y with inverse operations, will provide us with the exact set of steps that will undo the original function. Doing that here would mean we'd first square both sides to undo the square root, then add 3 to both sides to undo the subtraction, and finally divide by 2 to undo the multiplication. The equation we end up with, y equals x squared plus 3 divided by 2, is the inverse because it includes all of the inverse operations in reverse order of the original function. Therefore, g inverse of x is x squared plus 3 over 2. The last thing to cover has to do with specifics regarding what makes a function, and therefore what makes its inverse. You'll need to remember that any function can only have one output for each input. One common way to test this is called the vertical line test. By tracing a vertical line across the graph, we can check to see if the relation is indeed a function. If our imaginary vertical line crosses the graph in more than one place, the relation is not a function. But if it passes across the entire graph and only ever touches the graph in one spot, it is. We can use a similar tactic to also test whether the inverse is a function as well. But now, similar to how we switch the x and the y to find the inverse, we switch the vertical line to a horizontal line. This means that in order to test whether a relation's inverse is a function, we use the horizontal line test instead of the vertical line test, but everything else is the same. We trace this imaginary horizontal line across the graph, looking for a place where it touches more than once. If it never does, the inverse is a function, but if it ever touches the graph in more than one spot, the inverse is not a function. There's a lot to know about inverse functions, so let's review what we've learned. A function's inverse is another function that does the exact opposite, and we use the -1 power to express it. If we compose a function with its inverse, the two functions essentially undo each other, leaving us right back where we started, the x. We can figure out what the inverse of a function is by swapping the x and the y, and then re-solving the equation for y. And finally, to test whether or not the inverse is a true mathematical function, we can use the horizontal line test to see if our imaginary horizontal line ever touches the graph in more than one spot.
Let's check comprehension. So if you're watching the video, pause, take a minute, and make a selection. All right, we want the inverse of the following function, f of x equals 2x minus 3. The first step is to replace f of x with y. So we'll write this as y equals 2x minus 3. Then we're going to switch the x and the y. So we'll put an x here where we had the y equals 2y minus 3. Now keep in mind that we're solving for y, so the first step would be to add 3 to both sides. So we'll have x plus 3 is equal to 2y. -3 and +3 is 0. We still have to divide by 2 to isolate the y. So now we have y equals x plus 3 divided by 2. And that is answer choice B. Our agenda for this week, on Monday, again, you should get into the course daily for, I suggest, 30 to 60 minutes. Put that in your plan because we're starting something that a lot of you haven't seen, logarithms. And the first time that we are introduced to a concept, we need to have more practice until we get comfortable with it. So you should be getting into the course daily. But on Monday, we really should have gotten into 4.04, taken notes, doing the practice, and taking that first attempt on the quiz. I'm going to be updating those grades on Tuesday. That's my goal. But if not Tuesday, again, Thursday is our day to update math grades. So those updates should be done. Everything prior to Wednesday at midnight, that'll be updated on Thursday. Now, if you complete something on Thursday, it might not be updated until the following week. So just keep that in mind. On Tuesday and Wednesday, we're going to be covering live class. Again, the recordings can be found in the iCan along with the notes. And you can download those if you prefer to see it in writing, or you can watch the video that I try to record everything so that you can see it in its entirety. All right, so on Thursday, we're going to be moving into 4.06. Now, I'm trying to slow down the pace a little bit, but that doesn't mean that you should just ignore getting into the course every day because you need to stay on track. You've got another quiz that's due, 4.06, by midnight on Thursday night. So even if you're not ready, guys, take that first attempt. You have 3 attempts on your quizzes. Okay, and then we have small group on Friday. And I would say if you're not prepared to pass 4.04 or 4.06, then you should opt in for those small group sessions. All right, remember, reviewing vocabulary, we're going to start with that. So let's just talk about the word logarithm. Look up the word logarithm. How would you tell a 12-year-old what that is? If you've been going through the course, taking notes, watching the videos, really focusing on what's there, a logarithm is simply the inverse of an exponential function. So these are inverses of each other. This is written as, I'm going to start with the base, 2. 2 to the 4th power is equal to 16. So I'm kind of going in a clockwise order. 2 to the 4th power is 2 times 2 times 2 times 2 is equal to 16. Now, as we write it as the inverse, we write it as a log function. So we can go back and change this back to an exponential function if we start here. This is the base. And now we're going to go in a counterclockwise order. 2 to the 4th power is equal to 16. All right, if you're Googling things, looking up dictionary definitions, you might get off track, or you might get to a level that is confusing to you. So look in our Quizlet study set for Unit 4. This is where your vocabulary with formulas will be for you as you work through the material in the course. If I'm asking for a definition, I expect you to go there first. And then we'll agree on those and put those definitions there for us to refer back to. A quick review to find an inverse of a function. Again, this is a function, not a number. If this were the number 2 and we wrote -1 up here, the inverse of a number would be write it as a fraction and then make it positive. So 2 to the -1 power is 1/2. But that's not what it means when we're talking about a function. When we're talking about a function, we go through these 3 steps. Rewrite f of x as y. Step 2, swap your x's and your y's. And step 3, solve for y. Get y by itself. Today, we're going to determine the inverse of a function. We're going to continue with what we left off with last week. And then we're going to use that to solve and graph logarithmic functions. So we're going to introduce the logarithmic notation and understand what that is so that we can complete the exit ticket to show that we are attempting to move forward with this unit. Take it slow. And if you're not understanding, remember to go into the course, take notes, and practice. And then come in to help sessions or office hours if you have questions. All right, we want to find the inverse. This is just a review. We did this last week. So we're going to take f of x and replace it with y. So that's our first step. And then we can graph that. We can see it's a quadratic function. And if you remember our rules, okay, we're going to go down 4 units. So this is where our domain goes from -infinity to +infinity. But our y values start at -4 and then go up to +infinity. All right, so let's just go over those steps again. Let's see if we've got all this correct. We're going to replace f of x with y, which is what we did here. And now we're going to swap the x and y variables. So where there was an x, where there was a y, we put an x. Where there's an x, we put a y. Okay, and now we're going to solve for y. So the first thing that I would do is I would add 4x to both sides. So the left-hand side becomes x plus 4x. And then I would take the square root of both sides. So I need to correct this. There's a couple of mistakes here. So that's going to be the square root. Y is equal to the square root of x plus 4x. And this is the inverse function. So now we're going to use the horizontal line test. Move it up. If it only crosses in one place, we have a function. For our original function, we use the vertical line test. All right, poll in. How do you determine whether a function is an inverse of another function? Find the composite of the functions apply the vertical line test, add the functions, or multiply the functions. You can pause the video if you want to answer and then come back to check to see if you're correct. All right, to determine whether a function is an inverse of another, we find the composite of the functions. And then we place one inside of the other. If we get back our x, then we know that we have the inverse. Apply the vertical line test. This is where we start to see if we're starting with a function to know whether or not we can invert it. Add the functions. That's not correct. Multiply the functions. The answer is A. If a function is the inverse of another, then the composite of the two functions is equal to x. All right, again, which of the following is the inverse of f of x equals 3y? If you want to, pause the video and then come back to see if you got the correct answer. So we're going to start with y equals 3x. We're going to switch the x and the y, so this becomes x equals 3y. And then we're going to solve for y. So we just divide both sides by 3, and we get y equals x over 3, which is answer number B. Right, let's try another. Which of the following statements is true? A, before you look for an inverse, an original equation must pass the vertical line test in order to be called a function. I think that's correct. We've been saying that over and over again. Let's check the other answers just to be sure. All right, answer number B. If an equation has an inverse, then the original equation will pass the horizontal line test. No, it should pass the vertical line test, like we said in A. The inverse should pass, once we have an inverse, we'll pass the horizontal line test. All right, so that's not correct. C, if the function has an inverse, then the inverse needs to pass the vertical line test. No, the inverse is going to pass the horizontal line test, the opposite. So that's not correct. All functions have inverses, and that is not correct either. So the answer is A. All right, now we know how to do this. We can plot points. So I'm just going to quickly make a sketch. And if we're asked to plot the points -3 and 2, -3 in the x direction, 1, 2, 3, and then +2 in the y direction. So -3, +2 would be here. 0, 5, 0 in the x direction, and then go 5 in the y direction. So I'm going to start at 0 and go up 1, 2, 3, 4, 5. All right, and then the third one is +3, -2. 1, 2, 3, and go down 2. All right, you have the idea. Let me change the pen color. And whenever we want to graph the inverse of this function, we're going to exchange the x and y coordinates to graph. So now the inverse is going to be 2, -3, 5 and 0, and -2, +3. So we would go +2, 1, 2, -3, 1, 2, 3 would be down here. 5, 0, we'd go over 5, 1, 2, 3, 4, 5, 0, and then -2, +3. -2, +3, 1, 2, 3, up here. All right, so that would be graphing the inverse. So we did right here. Now today we're going to learn how to do this and more. We're going to write the inverse of an exponential function as a logarithm. So we're going to start using that notation. and then identify the graph of the logarithm. So we're going to build on what we know about exponents. Let me walk you through this example, and then you can help me through the next example. We want to know the inverse of this function. So step 1, we replace f of x with y. All right, step number 2, we're going to swap the x's and the y's. So this is going to be x equals y minus 5 to the third power over 2 minus 3. All right, now we're going to start trying to isolate the y. So the first thing I'm going to do is add 3 to both sides. So on the left, I have x plus 3. On the right, minus 3 and plus 3 is 0. So this is going to disappear. The next step is to multiply everything through by 2. So this is going to cancel out the 2 in the denominator here. All right, I'm going to multiply the left-hand side by 2. Let's go ahead and distribute that. 2 times x is 2x, and 3 times 2 is 6. So 2x plus 6 is equal to, on the right-hand side, we still have y minus 5 to the third power. All right, so the next step is to take the cube root of both sides. So we have the cube root of 2x plus 6 is equal to, now taking the cube root of a cube is going to leave us with simply y minus 5. And the last step would be to add 5 to both sides to get y. So y is equal to the cube root of 2x plus 6 plus 5. All right, now you help me through this. First step, yes, the first step is to replace the function notation with y. All right, so we still have this. I'm going to go ahead and do step 2 as I'm rewriting this. We're going to replace the x with the y. So it's 5y minus 1. And the plus 1's over here. It's not under the radical. Okay, and then I'm going to change this y to an x. Now the goal is to isolate the y or solve for y. So the second step would be to undo a 7th root, would be to raise this all to the 7th power. Ooh, I don't want to do that first though. Let's back this up a little bit. I want to subtract 1 from both sides. So it's going to be x minus 1 on the left. And on the right, now I'm going to raise everything to the 7th power. So we've got it, whatever we do to the right, we have to do to the left. Now over here, this is going to cancel out. Raising this 7th root to the power of 7, it's going to cancel that radical out. And we're just left with 5y minus 1. Over on the left, we have x minus 1 to the 7th power. All right, the next thing is going to be like we did previously. We're going to take that little constant that's dangling off to the right, and we're going to add the opposite. So we're going to add 1 to both sides. So this is going to disappear on this side, and then the last step is going to be to divide by 5. Divide everything by 5. So now finally, let me flip this around, is we have y equals x minus 1 to the 7th power plus 1 over 5. All right, what did you notice when I worked these two problems? Okay, we're going through the same steps that we did last year to undo the operations that we have in our original function to get our inverse. All right, so in class, we had each of these covered up and we revealed them one at a time. Let's just see how a domain restriction placed on a non-invertible function affects its inverse. So I'm going to start with the first one. And let's look at this. Let's go back to Unit 1 when we found roots are solutions. if we were to graph this, we know it's a quadratic function, and we can't take the square root of a negative number. That gives us, it's an imaginary number. So we can take the square root of 0, that's 0. So if we set this x plus 4 equal to 0, and we solve for x, we get x is equal to negative 4. So we can go as low as negative 4, but if we go to anything smaller than negative 4, let's say negative 5, we would get negative 1 squared. And when we try to replace the x with the y and solve, we're going to be taking the square root of a negative number. And we've got to toss out all of those imaginary solutions. So negative 4 is the smallest it can be, but we can go up to infinity in the domain. So x can be everything from negative 4 up to through infinity. Now when we take the inverse of that function, this is what we end up with. So the domain restriction, we've got to take the inverse and look at this carefully and evaluate this the same way we did the original function. So the domain restriction, negative 1 is the smallest thing it can be, and it can go up through infinity. All right, let's see if you can do this. So we have another function here. In the original function, the domain restriction is from negative 3 to infinity. When we write the inverse, the domain restriction here is from negative 7 to infinity. And if you're graphing these, you can see, and you should be taking the time to work through all the practice, you should be able to start seeing this and putting it together with your notes. All right, let's do one more. All right, the domain restriction here is negative 5 is the smallest x that we can have, but we can have anything up through positive infinity. When we take the inverse of that, okay, inverse of that original function, then our restriction becomes x can be anything from negative 9 up through positive infinity. All right, we can write the inverse of an exponential function as a logarithm. Now, doing this in class is not to replace going into the course content and practicing and taking notes on your own. This is not to replace going in and practicing on your own. All right, but let's just go through this quickly to get an idea. We've been doing this all along. We know to replace the function notation with y, and then we're going to take this equation that we just rewrote, and we're going to swap the x's and the y's. So this is x is equal to 2 to the y minus 3. We're going to add 3 to both sides. And I'll go ahead and swap the sides because I like putting my y's on the left. So I'll have 2 to the y. That's all I have left here because negative 3 plus positive 3 is 0, is equal to 3 plus x. So now I'm ready to write this, now that I have the inverse, as a logarithm. So this is written as log base 2, 3 plus x equals y. Now let's check. Take this, we're going to go in counterclockwise rotation. This is 2 to the y equals 3 plus x, and that does check. All right, we would do the same thing with this. See if you can write the inverse of this exponential function as a logarithm. All right, so we're going to replace the function notation with y. Y is equal to 3 to the x. Now, I didn't mean to write this way. Let's just practice one of the same kind. 3 to the x minus 2. All right, so we're going to swap the x's and the y's. So x is equal to 3 to the y minus 2. We're going to add 2 to both sides. So we get x plus 2 is equal to negative 2 plus positive 2 is 0, is equal to 3 to the y. All right, so now we're ready to write our logarithmic notation. The log of base 3, x plus 2. You don't have to put the parentheses around it. I just am to try to help the writing make sense to you, is equal to y. So let's take this, go in counterclockwise rotation. 3 to the y equals x plus 2. So check. That works. Now let's watch a short video. It's about a 5-minute video explaining a logarithm. We don't want to go too fast. We want to let this sink in.
What happens when you take a number to a certain power? You multiply the number by itself a certain number of times as dictated by the exponent. For example, 5 to the power of 3 equals 5 times 5 times 5. In general, the rule is that x raised to the y power equals x multiplied by itself y times. If we wanted to write a rule for this relationship in general terms, we could write it as x to the y power equals z, where z is the result of x multiplied by itself y times. In this equation, x is called the base, the number raised to a certain power. Y is called the exponent, the number that tells you how many times to multiply the base by itself. You are probably familiar with math problems that give you x and y and ask you to solve for z. For example, what is the value of 3 to the power of 4? Or which is bigger, 5 to the power of 3 or 3 to the power of 5? But what if you looked at the equation a different way? What if you knew the base and the result, but you had to solve for the exponent? In other words, how many times do you have to multiply x by itself to get z? In both cases, the equation at work is 5 to the power of 3 equals 125. The two questions are simply asking you to find different parts of the equation. That is what logarithms do. A logarithm is the power that you raise a certain base to in order to get a given number. It's just another way of looking at exponential expressions, which you already know how to work with. Just like addition reverses subtraction and multiplication reverses division, logarithms reverse exponential expressions. To make it easier to solve for the exponents, logarithms use a special kind of notation. The expression x to the power of y equals z in exponent form would turn into log base x of z equals y in logarithm notation. In logarithm notation, the thing that we're solving for is isolated, so it's easier to solve for, just like it is in regular exponent form. This might look confusing at first, but it's just another way of writing the exact same concept. These two expressions are exactly the same. They're just two different ways of writing the same thing. Logarithm form can initially look like you're taking x to the power of z. This isn't what it means. Don't get confused by the fact that z is higher up on the line than x. X is the base, but you're raising it to the power of y to get z. A logarithm is basically the reverse of an exponent. In an exponential equation, you have the power, and you're solving for the result of taking the base to that power. In a logarithmic equation, you already have the result, and you're solving to find the power. So what could you possibly want to use this for? Well, for example, let's say you're a scientist studying earthquakes. The strength of an earthquake is measured on something called the Richter scale, where 1 is almost unnoticeable and 9 is extremely destructive. Here's how scientists calculate the Richter rating of a given earthquake. Don't worry too much about this. This part is just an equation that takes the amount of force measured and adjusts it according to how far away the station is from the earthquake. The interesting part here is the logarithm. To get the number from 1 to 9, scientists calculate what power they'd have to raise 10 to get the adjusted measurement of force. Let's say that the adjusted measurement of the force of an earthquake was 10,000. How big would the Richter rating be? In other words, what power do we have to raise 10 to in order to get 10,000? You'll go over more techniques for solving logarithms in another lesson, But if you know anything about the powers of 10, you can already crack this one, because 10 to the x power equals 1 followed by x zeros. So 10 to the second power equals 100, 10 to the third power equals 1000, and so on. In this case, we've got 4 zeros, so we can tell that we need 10 to the fourth power to get to 10,000. Log base 10 of 10,000 equals 4. That makes this earthquake a 4 on the Richter scale, which is enough to shake your floors a little and knock some books off the shelves, but it won't be toppling any skyscrapers anytime soon. In this lesson, you learned about logarithms. A logarithm is the power that you raise a certain base to in order to get a given number. Logarithms are like a way to undo exponents. Where exponents are all about taking a base to a certain power and figuring out the result, logarithms are about figuring out what power you need given the base and the result already. Logarithm notation can be confusing at first, but as you use it, you'll get used to it. Just think of it as another way to write exponents. The expression x to the power of y equals z in exponent form would turn into log base x of z equals y in logarithm notation.
All right, 30 seconds. Here's an exponential expression. A to the b equals c. Which of the following is an equivalent expression? All right, taking what we know, we're going to write this as log base A. A is our base. So let's look for that. It's either going to be A or C. It's not going to be B. B is our exponent. A is our base. So A, log base A, go in counterclockwise rotation to C equal B. This is going to be our exponent. All right, so log base A, C equals B. So the answer is log base A, C, B. It's going to be C. All right, let's try another one. Which part of the logarithmic expression is the base? All right, the base is always going to be right here, so it's going to be A. The answer is A. All right, well, we're going to take a little bit longer on this one. Which of the following expressions are equivalent to each other? So we have log base A, B equals C. So how do we change that back to exponent form? Again, start with the base. A to the C equal B. Okay, so it's going to be 1 and 3. 1 and 3 only. This one, number 2, we would write as log base A, C equal B. So we don't have an equivalent for this one. So it's 1 and 3. Use your circle trick. All right, we're going to rewrite log 3, 9 equal 2 in exponential form. So start with the base, 3 squared equal 9. 3 squared equal 9. Right here. The answer is A. And if you check the others, these aren't equivalent. These aren't equal. 3 to the 9th is not 2, and 2 to the 3rd is not 9. 3 squared is 9. All right, keep practicing with that. Get into the course content. Now, I want you to go to use your QR code reader and go to our Padlet and then reflect on what we did. What are some of the things that you know about logarithms? How do they relate to exponents? Do you see any patterns? How did my mindset affect my work? Did I prepare for class? Did I look at the vocabulary? Did I watch the recordings? Am I participating during class, or am I off somewhere else not paying attention? All right, the next steps: finish the course material for 4.04, take your quiz on time, begin 4.06, look at the material in the iCan, continue taking notes, no type notes without getting permission. Now you can type notes and use them, but not to turn in, for me to evaluate. If you've not completed any assignment from Unit 3, especially the test, do it now. I can't help you unless you try. Again, check out the material in the iCan. If there's something that you need but you don't see it there, let me know and I'll try to get the support that you need. Don't get behind. This is our last unit. Just do it. And the way that it's looking right now, I'm going to be out testing. I'm not going to be here to hold health labs or be in office hours throughout the end of the semester. We've got testing coming up. All right, so finish this up. Complete our exit ticket. I'm going to go to joinmyquiz.com and enter in this code 12233523. Everybody needs to complete the exit ticket. Get in the habit of checking the announcements, communicating, keeping up with work, come into office hours, all of that. Everyone who's pushing through completing the part 2 of the Unit 3 test, looking at the feedback and using the video help in the iCan has brought their grade up significantly. So thank you very much. Keep working, and I'll see y'all next week.